All right, so today we're going to be starting Unit 8, and Unit 8 is all about systems of equations. So we'll be comparing two equations and finding their solutions. Okay, so today we're going to look at how can we find the solution to a system of equations by graphing. So we're going to be working on some graphing skills. All right, so remember, a solution set is the collection of all the points that make an equation true. Okay, so we're talking about all the points that make an equation true. So looking at number 1, this is a reminder problem. It says determine whether each point is a solution to the equation y equals negative 3x plus 4 graph below. So the way that we're most comfortable finding the solution is, I'm going to rewrite that equation over here so I can see it. Okay, is that we need to remember that this is our x and our y, and we're going to substitute those in for our x and our y. So instead of a y right here, now it becomes a 1 is equal to negative 3. And instead of an x, it becomes a 1 as well, plus 4. And then we're just going to simplify. So I have 1 is equal to negative 3 times 1 gives me negative 3 plus 4. Still just simplifying, I have 1 is equal to negative 3 plus 4 gives me 1. Since that is a true statement, it is a solution. Now, another way that we can check to see if something is a solution is to see if that point is on the line. So if I go check that point, 1, 1, it is on our line, therefore it is a solution. Because we know that it is on the line. So that's how we're going to check these other 2 points. Since we're focusing on graphing today, that's how we're going to check our points. So the next one was 4, 0. So we're going to go plot 4, 0. So 4, 0 is right here. That's not a solution. Because it is not on the line. If you were to plug in that point into your equation, it would give you a false statement. And the last one is 2, negative 2. Plot the point, 2, negative 2. That's also on our line, so it is also a solution. All right. So now we're going to look at how do we actually apply this to a system of equations. So a system of equations is a set of equations with the same unknowns. Okay, so they both have x and y. The solution to a system of equations is a set of all the points that make both equations true. It can't just make one equation true, it has to make both equations true. To find solutions, we are looking for the points that are on both lines. So that both should be in this blank. My bad, guys. That are on both lines. And the points where the lines intersect. Nope, that didn't turn out right, did it? There we go. All right, so looking at our systems down here, notice all these have 2 lines graphed, and we're going to be looking for the system, or we're going to be looking for the solution. So we want to know where the points where the lines intersect, or the point that is true for both lines. So if I look at system A, my lines intersect right at the point 3, 4. So this has one solution at the point, what was it again? 3, 1. Right at 3 and up 1. Now if I look at the system B, okay, notice that both of these points are not both of these lines do not intersect. They're actually parallel to each other and they're never going to touch. Since these lines do not touch, Okay, we're going to say that they have no real solutions. Okay, they're never going to touch, so they have no real solutions. And then last but not least, we have system C. Looking at this system, both of these lines are, oops, that didn't work. Both of these lines are right on top of each other, okay? They're the exact same line, okay? Just graphed right on top of each other. Since those lines are the same, okay, and they have every single point in common, okay, we're going to say that this system has infinitely many solutions. All right. So for two lines, you have three options. One solution, no solutions, or infinitely many solutions if you have two linear functions. All right, let's flip over to the back page and look at our next examples. So we can solve a system by graphing the equations and finding the intersection, so where the two lines touch. So if we look at this first one, we have solve by graphing by hand. So the first one we have y equals -5. Since this is just y equals a number, that's where we have to use our HOI. So that means it's going to be a horizontal line. Horizontal lines have zero slope and they're always y equals a number. So we're going to go to the y-axis at -5 and put a point. Since it's y equals a -5, we go to the y-axis, put a point on -5. And it is just the horizontal line going through -5. Okay, so there is our first line in the system. So that's going to be my blue line. Now I'm going to have my pink line. We have y equals x minus 3. To graph that, we have to remember that our y-intercept is 0, -3. So I'm going to plot a point at 0, -3. My slope is just 1. Okay, so that's going to be my slope. That means I have to go up 1 and over 1, up 1 and over 1. So we're just going to plot those points, up 1 and over 1, up 1 and over. I like to plot all my points, that way I just have a nice straight line, especially when I'm trying to graph on the screen like this. All right. So now that we have both of our lines graphed, we can look at where the lines intersect. And that's going to be right here. Okay, and you can see my point's a little bit more accurate than the line is. Okay, but it's going to be right at the point -2, 5, or -2, -5. So this has one solution at -2, -5. All right, let's do number 4. Looking at number 4, we're going to do the same thing. We're going to graph both of these. The first equation we have, going back to my blue, is y equals -1/2 x plus 4. So that means my y-intercept is going to be 0, 4. So I'm going to start by placing a point. My slope is -1/2. Okay, so since it's negative, that means my line's going to be going down. And we're going to go down 1 and over 2, because remember it goes rise over run. So down 1 and over 2. Down 1 and over 2. Oops, I misplaced a point, didn't I? All right, and I can connect all of those. Now for my pink line, I have x plus 2y equals 8. For this one, we're going to have to solve for y to graph this a little bit easier. So we're going to subtract the x from both sides. That'll give me 2y is equal to negative x plus 8. We're going to divide out the 2. Remember, you have to divide everything by 2. That'll cancel. Now I have y is equal to negative x divided by 2 gives me negative 1/2 x. 8 divided by 2 gives me plus 4. So now we can graph that line. So here our y-intercept is 0, 4. So we're going to plot a point. Looks like they're already going to at least intersect there. And then my slope is negative 1/2. So that means I'm going to go down 1 and over 2. Down 1 and over 2. Now notice that my points are all on the blue line already. So that means my line is going to overlap everywhere on the blue line. Since those lines are the same thing, and we can notice that the equations are the same as well, this is going to be infinitely many solutions. Oops. All right. And looking at the last one for today, it says solve by graphing by hand. The first one we have is y equals 1/3 x minus 2. Going back to my blue line. Oops. We know our y-intercept is going to be 0, negative 2. So we're going to start by plotting that. And my slope is 1/3. It's positive, so that means our line is going to go up. We're going to go up 1 and over 3. Up 1 and over 3. And there's going to be my first blue line. Now for my pink line, we have to solve for y so that we can graph this a little bit easier. So we're going to subtract the x over. Those will cancel. So I'll have negative 3y is equal to negative x minus 6. Remember, I can't combine those because they're not like terms. Divide out the negative 3. And I'll have y is equal to negative x divided by negative 3. The negatives cancel out, and I'll have 1/3 x. Negative 6 divided by negative 3. Negatives cancel out again, so I'll have plus 2. So my y-intercept is a positive 2. So I'll be at the point 0, 2. My slope, if we look at this, was 1/3 again. So we're going to go up 1 and over 3. Up 1 and over 3. So notice that these lines never intersect on my graph. We also know that they're never going to intersect off the graph either because their slopes are the same. Anytime your slopes are the same but your y-intercepts are different, then that means that these are going to be parallel lines, okay? And they're going to have no real solution. All right, so that's going to be it for today. Now you can move on to the Google form. Make sure you're finishing the video on Edpuzzle and completing the Google form to get your weekly points. All right, you can check back on the next day to find your next video.